Welcome back. This is the lesson the Measure module has been building toward. Process capability. CP and CPK answer the only question a customer really has. Can your process hold my specification? They dominate Measure questions on both exams, and they're the language of every supplier audit you'll ever sit through. We'll build the intuition, work an example by hand, then compute capability on 50,000 real measurements in the LeanProjax platform. Let's go. Capability is a comparison of two voices. The voice of the customer is the specification width, upper spec limit minus lower spec limit, the goalposts. The voice of the process is its natural width, 6 standard deviations, 3 either side of the mean, holding 99.7% of output. Divide them and you have CP, spec width over 6 sigma. CP of 1 means the process barely fits. Above 1.33, comfortable. Below 1, physically incapable. Defects are guaranteed no matter how hard anyone tries. But CP has a blind spot. It ignores where the process sits. A narrow process aimed at the wrong place still ships defects. CPK fixes that. Take the distance from the mean to the nearest spec limit, divide by 3 sigma. Off-center processes get punished. Centered ones earn CPK equal to CP. So remember the pair. CP is the potential. How good you could be if perfectly centered. CPK is the reality. How good you are today. CPK can never exceed CP. Worked example, by hand. Specs, 40 to 52. Process, mean 45, standard deviation 2. CP, spec width 12 over 6 times 2, 12, exactly 1.00. CPK, nearest limit is 40, 5 units below the mean, 5 over 6 in 0.83. Read the gap, potential 1.0, reality 0.83. The process is off-center toward the low spec. Shift the mean toward 46 and CPK rises toward CP. A free improvement, no variation reduction needed. Now the real thing. I'll use the LeanProjax platform. From the data playground profile of our 50,000-row dataset, I send the cycle time columns straight to a capability Sixpack. The run opens with every chart drawn, histogram, run chart, control chart, box plot, normality check, and our specs are already in place. Lower 30, upper 60, target 45. Read the tiles, CP 0.945, the potential, CPK 0.903, the reality, sigma level 2.7, and about 6,700 defects per million. Below the 1.33 bar, which is exactly why this project exists, and what Analyze and Improve will attack. Reading the numbers like an auditor. Sigma level short term is 3 times CPK, so the classic bars, CPK 1.33 is a 4 sigma process, the accepted minimum. 1.67 for safety critical, 2.0 is 6 sigma. Now the exam traps. CP needs both spec limits. One-sided specs use CPU or CPL alone, and that value is your CPK. And capability math assumes a stable, roughly normal process. Run a control chart first. Capability of an unstable process is fiction. Exam drill. 2 questions. Question 1. Specs 90 to 110, process mean 98, standard deviation 2.5. Compute CP and CPK. And which one do you quote when the customer asks, "Can you hold my spec?" Pause here if you need a moment. CP 20 over 15, 1.33. CPK, nearest limit 90, 8 units away over 7.5, 1.07. Quote, CPK. The customer lives with your reality, not your potential. Question 2, CPK sits far below CP. What's the cheapest first improvement? Take a few seconds. Center the process. Shift the mean toward the middle of the spec. The spread hasn't changed, but CPK climbs towards CP. Capability, from formula to 50,000 data points. Add CP, CPK, and the 1.33 benchmark to your formula sheet. Next lesson untangles the pair everyone confuses, CPK versus PPK, short-term versus long-term capability, and why your six-pack shows 4 different numbers. Subscribe and I'll see you there.